Unit 21, the second standing exercise. Number 4. This one. And number 4 is where I should have buttons. Number 4 is What's yours different? I don't know if that matters.
And we have the. Okay, so first we do the phasor diagram, right?
Yeah.
So what did you? How did you?
Don't even know because of the angle, but L is longer than C.
Wait. There's the maximum voltage across. Never mind, maybe about 20. Do you agree?
Yeah.
So we can easily figure x. Oh wait, we don't know the inductance, right?
I think I had to find out the question before.
Really?
Yeah, because that's what the value file was. And I got that one right. I just couldn't seem to get forward.
How did you get that?
I think I found what XL minus XC is.
Oh, okay. So you know that it's c minus x. No, sorry, xxl minus xc over r is tangent, right?
Yes.
And you know p. You know r and you know c.
Yeah.
And you do you have, yeah, you probably know that, right?
Yes.
Yeah, okay, so you know xl from here.
Mm-hmm.
xl is r tangent theta. Sorry, p plus x. So the question is in our notes. How do you find that notes?
That's what I wasn't sure how to do.
What
Oh,
do you try?
well, we know voltage and resist. Voltage in Z. Is that what you're showing next?
Yeah, it is.
Okay.
So Imax is just that Emax that we're getting over Emax.
That's right.
Is that how you read it?
Yeah. I thought 5 would have to be the same as 4. But I'm not.
What happened again? No, yes. What did you get?
For 5. I couldn't figure out 4, so I didn't know.
What's your for the like is it sine? It's a sine function, okay? Or a cosine. It's a trig.
Would it be cosine since it's offset from the generator, which is sine? Or is that one of the equations he gives us?
Why should it be a cosine? It's offset, but we can put that.
Oh, it's just offset by the phase angle?
Yeah.
Oh, so you just use that equation.
So VO. Yeah. What is it? Let's think.
Would it be E max sine of WT plus the phase angle?
Well, the elements, right?
Oh, okay.
Sine of W2 is a plus. And so, think of, let's not see the thing.
Yeah.
And the equation for E is E max times sine omega.
Yeah.
Hi. Okay, first of all, let's say that this is this one. BL is leading. So we need to shift it that way.
Oh, so is it actually a minus?
It should be a minus, but it's not. So we want like this. So this should be in fact minus. And then for some reason, we still have the minus.
put the enos in.
Well, sine is a y, right? Let's say, let's take this one. 0. In here, this is 0. But if we plug in 0 there, we'll have v of max times sine of minus v. Sine of minus v is positive or negative?
Negative.
Yes. Wait. I cannot get my head around it. Why is it negative? Oh, okay.
Is the answer supposed to be negative? Because I have a positive in my code equation. Because according to the graph, it looks like it would be negative.
Yeah. Yeah, actually. But looks right. Because if you put the zero time, you'll have.
Excuse me. Which number is this?
This is AC circuit.
Is it the first example?
Yeah, this is the right equation. Sorry about the minus confusion. I think this should be minus instead.
Oh, okay. That would.
This is unit 21.
Yes.
No, unit 21, the second part. This I just want to compare because we are similar problem. It's just AC circuit, huh?
Yeah.
Okay.
I think you're
Yeah.
or you're looking at the question.
Well, I didn't actually get number 6, but it's multiple choice. So
We'll come back then to AC circuit one. What's your question?
Yes. I'm with number 6, unit 21, on AC circuit 1. AC circuit 1. Number 6. I don't know why
And you need to find AC like 0.
Mm-hmm.
Can I remember? So you probably need a similar thing like we were before. You need an equation, right?
We need one.
An equation.
Yeah.
So what do you think? So we have this equation, right?
Mm-hmm.
And we know that C is probably offset.
C is what? Offset.
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 Yeah, we need to find the offset.
Yeah, the voltage at the capacitor.
What did we try?
I use the formula for finding the voltage across the capacitor, which is VC is equal to R max times XC.
DC equals what?
R max XC.
This is what?
That's the voltage across the capacitor.
Maximum.
Yeah, maximum voltage.
Do you know if you have a maximum voltage across the capacitor when
Come back.
you need voltage at time 0.
Uh-huh.
How do you know that you have maximum at time 0? That you not start somewhere, not at the maximum. You don't know that.
No, because I mean the reason I use that formula is the formulas that were given to us. If you want to find the voltage across the capacitor, that's the formula you use.
Maximum voltage.
Okay, maximum. Okay.
Because you have EMF as a sine function.
Mm-hmm.
So probably voltage across the capacitor is going to be periodic function too, which you don't know. You don't know whether you start at maximum time because you don't know. Right?
Mhm.
So what you need to do is you need the equation of this kind. And some trigonometric function of omega t plus or minus the offset. Because probably c is offset. Right? So VC max, you know, this is this I max times XC.
Mhm. Yeah.
Do you know I max?
Yeah, Amex. I found Amex in the problem. Amex is equal to E max over Z.
Yeah. And you can find Z, right?
Here, the impedance.
Yes, you can find impedance because you know R and L and C and
R and Y L.
R, L, C and W.
Yeah.
So you can
Yeah,
find
we can
impedance.
find it.
Okay, so this is good. So we know this is, you know, VC max. Now we need to decide about the function about the offset. Now offset is easy to find too. You have the equation tangent P is equal to XL minus XC over R, right?
Mhm.
So P is equal to R10 or 10 inverse. Right?
Mhm.
Now what? We need to decide which function we need to decide which offset. Right?
Mhm.
So what do you think we should do? I think what?
I draw a laser diagram, but you know,
Okay. How do you draw the
um, well, I guess at time 0, EM is maximum, or is it 0? At time 0, the voltage. Because don't we have to draw like the E voltage first, like the generator voltage first?
Yeah. Well, this is the only equation we know. At t equals 0.
Oh, it's 0. So 0, 0, so it would be 0. So we go like across the x-axis. Yes.
Or x-axis, yeah. Yeah, the resistor.
Well, no, that would be the generator
That
voltage.
will be generator voltage.
Yeah, and then you offset
So,
the resistors ahead of it by the phasing. Because it's in the
okay.
phasing.
A question. Yeah. A question is, at t equals 0, it means the generator, the voltage of the generator is 0. Okay.
How do you say?
I didn't actually get an answer. I haven't done that one. Is it similar to this one?
It's similar to what
No.
we had.
I was just going to show you that E equals to E max times sine omega t. And this is your.
Oh, so that's actually wrong.
No, I'm just saying the same equation. They work on different axes.
I thought 0 voltage was along the x-axis in the phasor diagram, but is that wrong?
I actually agree with this theory. Why did that one? Well, we can actually rotate it 90 degrees. I don't think it's going to change. Right? If we rotate it.
Mm-hmm.
So it shouldn't matter. Now, can you calculate the cosine? You know whether it's negative or positive?
I got a negative 23 point something
You get it
degrees.
negative or positive?
For the reactants.
For the phasing.
Oh, the phase. I got 31 degrees. Talking about the angle?
Yes.
Okay, I got 31 degrees.
That what?
31 degrees. 21, negative 21.
Well, I guess it's wrong.
1.7734. Yeah.
So phasing was negative.
Mm-hmm.
Where is the phasing? What should I do?
It's going down.
But won't the resistor leave the generator if the phasing is negative? Or is that wrong?
What did you say?
I thought that if the phase angle was negative, the resistor goes above the generator.
If the phase angle is negative, that means XL is greater than
Mhm.
XC. Right?
Yeah. It means that
No,
XC is greater than XL.
Yes.
That.
So
Yeah,
then it
XC.
goes.
Because
the
that
final,
should be negative.
Yeah, the final vector goes down.
Yeah. So,
And this is what it is.
There's Z. That's the impedance.
oh yeah, oxygen fluid. Well, but I thought we were talking about where the resistant VR would go.
Yeah.
Oh, I thought VR would go
It
above.
confuses people. But
I thought VR would go above the generator when the angle's negative.
Well,
It doesn't.
you have capacitor that's so you're in general you have VL first,
Mm-hmm.
then VR
Mm-hmm.
and VC.
Yeah.
They're perpendicular to each other.
Yes.
So if your phase angle is negative, that can happen if and only if this thing
Yes.
is less than 0. It means XC is greater than XL. So this is in fact longer
Yeah.
than this. It's just shortened. So your E will be this way.
Oh, yeah, that's what I thought.
Superposition.
That's what I thought.
Mm-hmm. And then the resultant vector is going to come.
This one is on top, right?
Yeah, that's why that.
That's why you thought it's on top.
Yeah. Okay. That makes more sense.
So the arrow goes up.
Well,
Yeah, yeah, it goes.
you see how it worked out?
Mm-hmm.
You,
Yeah.
you understand why it's on top?
No, I don't.
Okay. Let me explain it again. So in a general phasor diagram, you have VL, right?
Mm-hmm.
is always 90 degrees ahead of VR, which in fact, which is also 90 degrees ahead of VC. If you have a negative phase angle, that means VC is longer than VL. So let me do it longer than. Right? So that when I sum those two vectors, the resulting vector is pointing down. So this will be what?
That will be the impedance. It will be Z.
Yes, but Z is connected to the generator, right?
Yeah.
So this is the voltage of the generator, E, right? But this being the phase angle, right? Negative one.
Yeah.
So what we have here is that VR is ahead of this by the phase angle. Which we have here, we just rotate this picture up. And this is
So it's always the generator voltage is always on the x-axis. Should always be located on the x-axis.
well, we just took it because we have generator voltage as a sign, omega t, right?
So you have to rotate it. I mean, I just like.
Well, we just do it that way. We could pick a different random angle, I guess, but it's convenient to draw it this way.
With the facing angle negative, because I thought it should be in the negative quadrant. It should be below the. Yeah, I mean, with the angle being negative, will it still be negative if it goes up in the first quadrant?
Yeah, you just rotate the picture. They're gonna stay like with this angle, which is pointing. If you move it, you can move it to the negative quadrant if you want. Negative phase angle is just shows you the relative position of these.
Because that's what I did. That's what I did here. I mean, see, because the resultant vector is going to point downward, and then you have the impedance, and then the which is.
Well, the impedance is you just rotated it this way, and this is along the x-axis. Same idea. Okay. I can redraw it to look like this.
That's why I was like,
you have it as VR is here.
Yeah.
And this is here.
Yeah.
You see, if I rotate it by P, it's going to be the same.
Yeah, that's what I did, so I was a bit confused. Okay. But if you say that, I mean, it can go the other way, I can still accept it.
Well, phasor diagrams just shows you relative position of each of the vectors. Okay. So it doesn't matter if we rotate it or not. We just took this along the x-axis. Okay. We could as well take it that way.
Yeah.
Okay. Do you want me to continue with this picture? Because you have it this way?
Yeah, but I mean, which one you prefer that also?
Okay. I will continue with this one.
You prefer?
I understand that one.
Okay.
I don't.
Okay, let's then continue with this since it's less confusing. So VL is here, right? Now you need the function like for DC. remember that I wrote you? This is what we need to find.
Yeah, VC.
We need VC relative, well, we know VC max, right? We don't know this function, and we don't know plus or minus.
Yeah.
So how is VC located relative to E? Did you understand my question?
Yeah, the question is how VC is located relative to E.
Yeah. So E is leading VC by what?
It will be by 90 minus 5.
I would work minus. Right?
Mm-hmm.
So if I were to draw the E function, it's a sine function, remember, by, well, it's given. So this is my E. How do I draw the C?
How do you draw for C?
VC.
Because E is leading VC by that angle.
Which way do we need to shape VC at this point? For E. Left or right?
I think VC is going to be shaped to be left.
Yes. So, something like this. Well, it's a bet they shouldn't.
Mm-hmm.
No.
Yeah, no. It's
Well, you understand me, right?
yeah.
Like this. This is VC. So what's my function? VC is VC max. Times what much?
It should be sine.
Okay.
Omega t. Should be minus 5. That way probably.
Which way did you move?
We move left.
So plus or minus?
It should be minus. If we move left, it should be plus.
Okay, let's take this one. 0, right?
Yeah.
I'll write plus V. So if we do plus V,
Mm-hmm.
wait, you said minus.
Yeah, sigma. That's what I said.
So if we do, so according to this picture, for VC, we should get a negative result, right?
Yeah, that's what I
Well, according to this
Yeah,
graph,
yeah, yeah, yeah.
right?
Mm-hmm.
We plug in 0 here. We got sine of negative
Yeah, 5.
5. If phi is I didn't write. I didn't go to the picture. Sorry. I shifted it the other way.
Yeah, that's why I want to. Instead of being left, the drawing it became right.
So I need to shift that.
Yeah.
So now just
Yeah.
start here.
You start there? Yeah. Yeah, yeah. Mm-hmm. Now it's okay. Yeah.
Now it's right.
Yeah. But it's still passing the middle of this one. It still pass at the same point. I mean, you say it shouldn't pass at the same point. The last one, yeah. No. Oh, yeah, yeah, okay.
Now it's totally right. So let's take 0. Plug in 0 here. Sign of negative p is positive or negative?
Plug in 0 there. You say sign of what? Negative what?
Plug in 0 here.
Mm-hmm. Yeah, if you plug in 0, the entire omega t becomes 0.
Yes. So what you have left is Vc max times sine of negative p.
Yeah.
Sine of negative p is positive or negative?
Sign,
If p is 21.
AT is minus 21. Okay, it's 21. So, minus 21. It's negative.
And V1?
Huh?
And V1?
And V,
No, what V1?
we want positive. Okay.
So just as a rule of thumb, when you're for x-axis, the signs are opposite. So if you're shifting it left, you're adding a plus there.
Okay, so we're looking for.
Now for every t.
See, I understand it now. Because it's shift left. It's shift left.
Yeah.
So it's on the positive y-axis.
Well, yeah, I was just trying to say that when you're shifting a graph leftward, now to every x you're adding additional little bit. Does that make any sense?
Yeah.
Like, before that you had to take a bigger t to get to where you are on the graph. And now you're just adding that as a free bonus to every of the t. So you have to shift it. To shift it left, you have to add a base there. Right?
Yeah.
But then I have a question about this part here. We need, what's the angle between E and BC?
E plus B.
angle between E and BC, yeah, is 90 minus 5. So this should be good. I don't know where I had it from.
Well, we can simplify this like function and co-function that pi over 2 angle
Oh, so we just
from
use
each other.
cosine?
Plus or minus.
Oh, shoot.
Be careful with the signs as well. So when you have sine function, we are shifting to the left by a very big angle, right? So this point is transferred almost here, right? Well, it's still less than 5 over 2, so here. So now this point is here. I label it 1. This is 1 point.
Mm-hmm.
Because we're shifting it. Oh wait, pi over 2. Pi over 2 is 90. 90 minus 21 is 4.
It would be
69.
69.
Well, here.
Mm.
No, this is right. This is 1. Because pi over 2 equals 45. We are over 45, but less than 90. Oh, wait, pi over 2. So it's here. I'm confused.
I just did it on my calculator and it says you just use the same sign.
So you're not
It says sine 90 minus phi would equal cosine of phi.
well, you have sine of omega t minus phi plus pi over 2.
Oh, so I guess you do change the sign then.
And you need it in terms of difference.
In that case, it would be negative cosine.
So when you're shifting sine of, oh yeah, that's what. Never mind about the t. So when you're shifting sine, imagine you have sine of x plus pi over 2. So every x you're shifting by pi over 2 that way. Pi over 2 is here, right? Now this is y prime, 1 prime, 1. So you're going this, 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 this. So now it's a cosine. Positive or negative? Positive or negative? So we can just plug in, let's say, pi over 4. So pi over, sine of pi over 4 is positive. Right?
Mm-hmm.
Plus pi over 2. So pi over 4 over 2. So we're negative. Should be negative cosine, right?
Yeah.
Well, we can rewrite this as VC max times cosine of omega t minus
Mm.
Does it make sense or should I explain?
Oh, you have
Minus.
minus.
Seems right. So with this whole shifting business, maybe forget about this graph. Maybe it's easier to explain like this. If you have sine of, let's say, pi over 4 plus pi over 2, and you want to write it in terms of cosine, because functions and cofunctions are related by pi over 2. So cosine pi over 4. Now, you need to determine the sign, whether it's plus or minus cosine. Now you look, sine of pi over 4 plus pi over 2 is negative, right?
The answer? I mean,
Well, when you have this unit circle,
Mhm.
this is sine, this is cosine. When you have pi over 2 plus pi over 4, it's here. Sine is positive, right?
Yeah, sine is positive.
Wait. Actually, sine is positive.
No.
Yeah, it's positive.
It is.
Mm-hmm.
Cosine pi over 4 is positive.
It's
Plus.
I was ignoring the minus of the phi when I was looking at this stuff.
No, minus. I just replaced this by omega t minus like this. So I want to write sine of omega t minus p plus pi over 2. I want to write that in terms of cosine. So it looks like it's going to be positive cosine over minus p.
Just to make it clear whatever you want.
Yeah, really.
Mm-hmm.
That should be a positive function. Anyway, answering your question, what's going to happen at 0? You just plug in 0.
Yeah. And the answer is going to be positive, isn't it?
Yes.
That's what I was struggling on.
Sorry about this confusion.
Mhm. And then maybe one last thing. Okay, this question, which of the, yeah, we don't have, no, it's not working, so it's just an analytical stuff. So which of the following statement is true? I've been struggling with that. So the voltage across the generator is 0 when the magnitude of the voltage across the inductor and capacitor maximum. Yes, I mean, I think that makes sense. Hmm?
Look at the phasor diagram.
Mm, yeah, no, the voltage across the generator is 0 when the magnitude of the voltages across the inductor and the capacitor are maximum. It means that when both of them are at their maximum, no, it's not right. It's not right. The current in the circuit is 0 when the magnitude of the voltages across across the inductor and the capacitor are maximum.
Current is maximum when voltage across the generator.
Yeah. But not with the inductor and okay. But then they say the current is zero. They're not saying the current is maximum. But they say the current is in the circuit is zero when the magnitudes of the voltages across the inductor and capacitor are.
Well, current in the circuit is in phase with the generator.
Yeah.
So with the generator voltage, is it zero when the magnitudes of the voltages? We checked it in the first statement.
In the first statement, they say the generator, the voltage across the generator is zero when the magnitude of the inductor and capacitor are at maximum.
Yeah, we
said
figured
no.
that this is wrong.
Yeah.
And then the current is in phase with the generator voltage.
Yeah, so I mean it's also wrong. Then the magnitude of the voltage across the generator is maximum when the magnitude of the voltage across the inductor and the capacitor are maximum. Yeah. I think, yeah. Because from the phasor diagram, I saw E max, and then V max and C max. And so there is no time there's no time when the magnitude of the voltages across the inductor and capacitor are maximum of those ones. They have maximum voltages. So I'm looking at this. I'm looking at the magnitude of the current in the circuit is maximum when the magnitudes of the voltages across the inductor and the capacitor are maximum. So you see, like finding V max C, you have to use R max. And then when you find V max L, you also have to use R max. The proportional.
It says current in the circuit is zero when the magnitude of the voltage. Sorry, I confused you. Current is not in phase with the generator. Current is in phase with
The resistor. Okay. Yeah, because current is in phase because VR is equal to the current. Yeah.
Sorry for confusion. So when and they're 90 degrees from each other. So when this is zero, these are not.
Okay. Okay, yeah.
Sorry.
Yeah. You looking a little bit confused this morning. Why? Did you go to econs class? I didn't see you. Yeah. It was very cold this morning.